Hi everyone, this is Tamu. Welcome to my channel, The Cloud Security Guy. In case you're new here, I talk on a weekly basis about things like cloud security, artificial intelligence, and general cybersecurity career advice. So today we are going to be continuing on our journey on the CCSP, the CCSP crash course. The CCSP is the cloud certified cloud security professional certification. It's one of the hottest cloud security certifications in the world. And what I'm doing is I'm doing domain by domain. I'm covering it. This is a completely free course and this is a crash course. So I'm basically covering all the domains and doing a good revision if you're preparing for the examination. So hopefully this will help you out and give you a good foundation to revise and just build upon the concepts you've already learned. And like I always do for each domain, I give a disclaimer. This is a crash course only. If you have not done the practice exams, if you have not read the book, if you've not made notes, this video will not magically make you pass the exam. This is for revision only and for clearing up your concepts. It's always good to have a revision. I would suggest you look at this video like 1 or 2 days before the exam, just so you can get a fresh perspective about the concepts and it'll revise you the concepts. Just reading the book and the same things again and again, it gets boring. So that's fine, mate. But remember, this is just a crash course. Okay, so and please guys, do if you like this video, do like and subscribe to this channel. That will really help the channel to grow and for me to make more videos. So today we're going to be moving on to cloud platform and infrastructure security. So the CCSP domain has around CCSP has around 6 domains. Okay, within the CCSP common body of knowledge, these are basically the 6 topics which you have to master in order to pass the exam. Okay, so the one we are covering today, which is cloud platform and infrastructure security. This counts for 17% of the CCSP exam, and it focuses on the practical matters of securing a cloud platform and its infrastructure. So basically, we explore what makes up a cloud virtualized environment and how it relates to the physical environment down. And it builds upon the previous domains, how they've worked. Things about like virtualization. You're going to learn what it takes to design a secure data center at the logical and physical layers, identity and access management, even business continuity and disaster recovery. So even like cloud is so much more redundant than on-prem, but still you need to make sure those like specific controls are there. So this is what we're going to be covering today. So let's get started. First topic is cloud infrastructure components. What does that mean? Cloud infrastructure is made up of many parts. Each of them is very important. You can find many cloud infrastructure components. The same thing you can find in on-prem also, but the way they work in cloud might be different. So aside from the infrastructure concepts that you're already familiar, cloud also introduces some new things which I'm going to go through. So first of all, let's take a look at what does the cloud infrastructure components are. So you have the physical environment, right? You have things like networking, virtualization, which is very important, compute resources, network resources, storage resources, and the management plane. So you can think of these are the layers on which the cloud is built upon. So let's start right from the bottom, which is the physical environment. A lot of people think that the cloud is stored in some like virtual world, but the cloud also has a physical environment. The cloud is just you're moving to somebody else's data center, right? So it is running on actual hardware located in actual buildings, and a single one of these buildings or data centers can have hundreds and thousands of servers, switches, and other hardware components. And a single cloud environment is usually made up of several of these data centers spread across multiple locations. You can go to the AWS website, just Google AWS regions and availability zones, and you'll see that. Okay, so when we talk about the physical environment, it provides guidance. So what are we talking about? The physical environment, what are the things which are important for a cloud infrastructure? Well, there is the physical access. You have to define controls for who can access your physical servers, access control. So for power and networking, your transmission medium, you have to define like so nobody can come there and damage it or disrupt it or tamper it. Physical access monitoring. So you have to have like security guards, people to respond to physical security events, physical access logs, security monitors, emergency power. This is quite important. Cloud computing is all about availability, and you can imagine what will happen if AWS goes down or Microsoft Azure goes down or Google goes down. That will be like a nightmare for so many like companies across the world. Fire and water, data damage protection, that's, I don't need to explain that. And of course, asset tracking, monitoring and tracking. So as cloud provider, you need to keep track of each and every server and the hardware components, and you have to make sure that they remain in authorized locations. Okay, what else is there? And right, what do you call, while the underlying technologies in cloud computing, they are very similar to like a normal data center, but it's just the scale we are talking about, right? The scale is so big. And when cloud providers, they think about data centers, they have to think about like several critical considerations for a cloud physical environment. First would be the data center location, right? So cloud service providers, they go through very detailed assessments when determining where to build their data centers. It's essential that CSPs, the cloud service provider, they have to pay special attention to the availability and natural disasters, like natural and man-made, which can happen if a data center gets taken out. You have to think about cooling, sufficient and redundant power and cooling. I mean, you have hundreds and thousands of servers providing services to like thousands of customers. So you have to make sure you have enough power, enough cooling to safely run all that hardware. What happens if your primary power or cooling systems fail? You have to make sure that backup is there, right? The good thing is Azure, AWS, Google, all these big guys, they have so much budget, so it's not that difficult for them. And sufficient and redundant network bandwidth. So similar to power and cooling, I mean, you have to make, the CSP has to make sure that they can support the data needs of all their customers with enough network bandwidth. And having enough bandwidth ensures that the cloud is always on and the customers can reliably access their resources from anywhere in the world, right? So all of this, you can imagine it gets quite expensive, right? Redundant cooling, bandwidth, transmission, and you have to provide security also. It's like all of these are very big, expensive. And the thing is, because large public clouds, they have so many customers, they can have that economy of scale. I mean, if they were just running their own data centers, they wouldn't be able to justify it, right? So we're going to dive deeper into each of these concepts, but just to make you understand. Okay, what else is there from the cloud infrastructure? Networking. Networking is the cornerstone of cloud computing, right? Because the only way customers can access their environment is through networking, right? You can imagine what would happen if something like some issue happens to the network. Now, while managing the physical network is completely the responsibility of the CSP, but the every CCSP candidate, you have to understand there are some key functionality in cloud networks. There are some concepts. Let's go look at them one by one. Okay, the first would be routing, right? The process of what's routing? The process of like forwarding network traffic between endpoints on the cloud network or between your cloud network and an external network. Filtering, you have to selectively allow or deny traffic, right? You don't want to allow all the network there, which can be malicious. Rate limiting, this is basically controlling the amount of traffic into or out of the network. Address allocation, this is assigning one or more multiple IP addresses, right, to a cloud resource. This can be done statically or dynamically. Bandwidth allocation, this is basically the process of sharing network resources between multiple users that are on the same network. And how you can imagine how important this is for multi-tenant environments. And of course, asset monitoring and tracking, right? You need to make sure everything is being tracked and you know where this is. And a very, very important part of this is networking is software defined networks. What does that mean? I mean, we talked about virtualization, right? Like VMs are software instances of actual servers. Similarly, software defined networks, they are like basically virtualized networks. Pretty much nowadays, you can find pretty much any traditional hardware available as a virtualized solution. And basically, they form the basis of most public cloud networks, this software defined networking. You're basically using software to communicate with the underlying infrastructure. And in some cases, it gives you better security. But just to understand, software defined networking or SDN, it's an approach to networking that uses software based controllers or APIs to communicate with the underlying hardware infrastructure. Okay, this model is different from a traditional network, which usually uses dedicated hardware, right? You have routers, switches to control network traffic. So SDN and create and control a virtual network or like control a traditional hardware via software. So the key difference, just understand, between SDN and traditional networking is infrastructure. SDN is software based, where traditional network is hardware based. And because the control panel is software based, the control layer, so it's much more flexible than traditional networking, and it allows administrators to control the network, change configuration setting. You can provision resources all from the centralized user interface. And there are security differences also, because you have more visibility and the ability to define like how you want to configure it. It gives you many better security in many ways. However, because there is a central control layer and a centralized controller, securing that controller is very important, because if somebody is able to compromise that, you can imagine what will happen, right? They will have access to all the underlying hardware also. So that was networking. So now we moved up the layer, so to compute. Now compute power is a big deal for cloud consumers, right? This is basically how you get data. You get servers, you get what do you call storage, you get other things like containers. So just like in traditional data center model, what happens is you get like compute power, GPU, CPU, and processing RAM, right? What's unique in cloud environments is that these compute resources are allocated to different customers, right? Like the one hardware, one physical server is divided up, and it's on a multi-tenant model. So it's being separated and distributed to like multiple customers, and it's completely transparent to them. They are not aware of the different changes which are happening. And the two things you have to be aware, two terms, which is virtualization and containerization. So let's look at them. What is virtualization? We've already discussed this before, but basically what you do is you take a physical server and you create virtual resources from it, like servers, desktops, operating systems, and on. And this is the pretty much the main technology which powers cloud computing. Okay, this is how multi-tenancy and scalability is possible. It separates compute environments from the physical hardware. So basically multiple operating systems and applications are running on a single machine. How is that happening? All of this magic is happening to a software called a hypervisor. So it's a layer, it's a computing layer on top of the hardware that allows multiple operating systems to run simultaneously on the same piece of hardware, which each operating system, it's getting resources, right? And it thinks it's getting its own dedicated resources. So basically it's the hypervisor which is virtually dividing that computer's resources among several virtual machines, and it's the one which is managing all the sharing between the resources. So there are two types of hypervisors, which is type 1 and type 2. Type 1 hypervisor, it's also called a bare metal hypervisor. Basically it runs directly on the hardware, and type 2 are software based and they run on the operating system. So you can imagine that there's a lot of benefits from there. Let's take a look. So virtualization security, right? We talked about type 1 hypervisor and type 2, right? So like I mentioned earlier, so the two categories of hypervisor. So type 1, it's running directly on the hardware, and type 2 is running on the host operating system. From the security perspective, type 2 hypervisors have a greater attack surface, right? Because of the vulnerabilities associated with operating systems and applications that reside on the OS. But type 2 also needs to be secured. Type 1, sorry. Type 1 also has to be secured. But just remember, there's from the attack perspective, attack surface, it has a lower attack surface than the software based, because of the software based vulnerabilities that also gets introduced. And yeah, when you, despite all the advantages which we have of hypervisors and virtualization, you as a CCSP candidate, you should remember some challenges. First would be the hypervisor security. I mentioned it earlier, but like I said, this is a software, right? That is sitting between the host and the guest, like which is the VMs, between the hardware and the VMs. And as a result, it can be a very critical point of focus. So you have to make sure that the bad guys don't find some missing patches and all that and get to it. If you are able to compromise the hypervisor, you pretty much have access to all the VMs. Okay, so one cloud tenant can get compromised and compromise another tenant's data also. After that is virtual machine security, VM security. So virtual machines, like I said, they're nothing more than like virtual files, like what do you call, which are sitting on like a virtual software based operating system which is sitting on top of that. And the same thing, so they are built based on images, right? So VM image is susceptible to compromise, right? Somebody can compromise that image. So you need to make sure that they are encrypted. You put things control like hashing, which we talked about. Encryption should be there, hashing should be there, should make sure that the confidentiality and integrity of the VMs is maintained. And network security. Networking security, like we talked, network traffic between virtualized environments. It cannot be monitored and protected by physical controls, right? Like network-based IDSs, you must have appropriate controls, like software-based, cloud-based controls, okay? Like to monitor the data which is there. And resource utilization. So if not properly configured, you know what can happen? A single VM can exhaust that hardware's resources, leaving other VMs out of luck. So resource utilization is where the concept of like the limits we talked about comes in handy, right? You can put in limits to make sure that the VM will not exceed it. So it's quite important to do, because if you don't put a limit on what the VM can request, it can pretty much like do a denial of service on the other VMs. It will use up all of the processing power which is there. Okay, that's virtualization. So now let's talk about container. So container, you can think about, is the next step of virtualization. So it takes the concept of virtualization of VMs to the next level. And what it does is it packages all the necessary code configurations and resources required to run an application. But unlike VMs, containers don't have the OS. So they don't need an OS. Instead, they have like a container engine which is running. So like I said, the difference between VM and container, VMs, what they do is they abstract the hardware, right? So you're not concerned about what hardware is there. A container, it abstracts the operating system. So you don't care what operating system is running. The container will handle like all the dependencies and everything. So this is the point. But the container, like I said, they have the same risks. They have things like images, they have which have to be scanned, and you have to make sure that nobody, like, they don't have vulnerabilities, they're being patched. So most container technologies, they come with support for managing this, but you have to ensure that you're not spinning up containers which haven't been properly patched or managed. So if you want to look at the difference between the two, this is how it looks like. So you can see on the right, they have the physical hardware. On top of that is the hypervisor, and then you have virtual machines. But all of these virtual machines have a guest operating system, right? And with the container on the left, you can see you have the hardware. On top of that is the host operating system. And then on top of that, you have Docker. So you have a single operating system, and the Docker engine, the container, it's managing all the containers. So that's why containers are much faster and they are much lighter than VMs. They're much, much faster because they don't have all this waste happening, right? All this guest operating systems which are present. So lastly, we're going to talk about storage. So at the most fundamental technical level, cloud storage isn't that different from your traditional data center storage. I mean, we talked about, when we talked about infrastructure as a service, we have usually two categories, which is volume storage and file storage. So volume storage is similar to traditional your storage, which is used when cloud it's allocated to a VM. It's just like a hard drive which is attached to that machine, right? And or what do you call object storage or file storage? It's like file storage that's not attached to any particular VM. It's like a folder, right, where you're putting in files, and you can, what do you call, access your files like AWS S3. And volume storage is elastic block storage. So this is like a, just think volume storage is hard drive, and file storage is like a folder where you're putting files and objects. Okay. So this is how it happens. Okay, so moving on, we're talking about, now we've moved on to the toppest level, which is the management plane. So the management plane, in cloud computing, it's the interface. I mean, it's the visual interface you see when you log into AWS or Azure. It's the set of functions and supports, it gives you full control over the cloud environment and the hosts. So it's typically restricted to highly privileged, administrators, and with limited abilities given to other customer, lower level admins. So they allow you to pretty much do everything, right, on the cloud environment. You can provision resources, storage, hardware, in networking, pretty much everything you want. And and usually it's either a visual interface or through the command line and APIs it's exposed. So like you've seen it, right? AWS refers to itself as a management console. Google is called Cloud Console. Azure is called the Azure Management Console. Basically, it's the same thing. But just remember, because it gives you a consolidated view and it's a single point access into your cloud environment, you have to lock it down, right? You have to make sure that the full access is not given to the large amount of people, and you have to make sure that the permissions are there. And despite the increased risk which is there, management plane also gives you a lot of security because they give you a full view of all your cloud resources. You're able to examine your cloud assets, and you know exactly what you're running and how it's configured. So there are a lot of benefits also there. So this is the example of the AWS one, the one I was talking about, right? You can see there's a full, like, pretty much everything you can see from here, you can access from here. Similar things are present in Microsoft and Google also. And this is an overview of the cloud, the one which we talked about earlier. So we've covered all of them, right? We've covered the physical environment, we've covered the virtualization, the compute, networking, storage, and the management plane. So let's move on. Now, designing a secure data center. So, cloud customers, we are moving their data to the cloud at a rapid rate. So many customers are pretty happy, right? They want to go away with infrastructure and data center, and they just want to focus on designing products. And other customers are migrating to the cloud because they have like regulations and security which they don't want to worry about, right? But you have to make sure that the confidence is there, right? How do you know that your data you're giving up to the cloud service provider is like secure? And how do you know that the data center is secure? So as a CCSP, you have to understand the concepts we have behind the logical design, the physical and environmental security controls, and the other controls. Every CCSP candidate have to understand this. So let's look at logical design first. So logical design. So when you talk about software design, is very, very important, right? Which logical data center security controls. We're going to discuss later in other chapters. But if you remember, we talked about zero trust, right? So traditionally, what used to happen is everything used to be within your perimeter, right? Outside your perimeter and within the perimeter, everything is trusted. So if someone was able to compromise the perimeter, now you have a big problem, because that guy, he can horizontally move and to pretty much lateral movement, what they call it, to pretty much any other resource, right, and compromise it. So this is why the concept of zero trust was made. So what is zero trust? If you remember, so zero trust is basically that you have to authenticate pretty much everything. So every single request, it goes to a single policy, and from there it's assessed, right? You look at it from where the location is coming, who the user is, like you don't trust any resource. So identity and authorization are always verified. So this by implementing zero trust, it prevents the common risk which I talked about, which is like compromised accounts being used to horizontally move, laterally move. And because they depend on the zero trust, it enables these technologies and processes. It's not a concept, it is a concept, it's not a product. That's what I meant. And you on top of that, you can build things like network microsegmentation and granular accesses. But this diagram shows you how zero trust. So this is your traditional model which I talked about, and this is a zero trust model. It's very, very important to understand. So this is from the logical design. The next one is the physical design. Now the physical design includes the actual data center building, the location, the policy procedures which are there. All of those things you have to understand, right? You have to understand the geographical location, where it is. So like where it's located, is there any risk of any natural disasters happening? Secondly, you have to understand how the building, like the availability, what are the materials and the thickness of the building walls, number of egress and ingress points, type of perimeter fencing, what are the locks, do they have redundant electrical and telecom suppliers, right? Apart from that, of course, physical security, which is very important. Somebody should be there to make sure all the only authorized personnel are coming in and going out, and visitors have to be prompted, verified. And of course, auditing and testing, right? You have to make sure that your data centers, they're certified to requirements like SOC, PCI, and all that, and they're audited and they're accredited by third-party providers. So you have that sense of comfort that the data center has been secured as per best practices. Okay, so now environmental design. Now it is very important as a cloud security professional. You have to pay attention to the environment in which your systems are existing. And when you're designing a secure data center, you have to consider a few environmental concepts. Temperature. Now, this might seem strange, but let me tell you, if you have ever left your computer running for a very long time, you might have felt it get pretty hot, right? So imagine a few 100,000 of those computers, each running multiple user workloads, and you've got your own overheated data center. Temperature control is very, very important. It's one of the biggest concerns in a data center. Ensuring that your servers don't overheat is critical, right? And failure to properly manage that temperature can lead to massive availability issues. So you have to pay attention to where servers exhaust their heat and how you're monitoring rack temperatures to make sure that the cooling is properly maintained. Next one is humidity, right? Humidity is water in the air, and water is very bad for electronics. I think everybody knows that. Humidity has to be monitored and controlled. But 50 to 60%, usually, I think that's the recommended range. And then you have alarms and systems built in, right? Other one is electrical monitoring. A secure data center, you have to monitor your electrical levels and trigger backup generators during outage. Also to watch for energy spikes that can damage sensitive equipment. And lastly is fire suppression. So they're an absolute must. I think it's a mandatory requirement in most data centers. Not only do they keep data center personnel safe, but they stop preventing widespread outages and data loss should a fire happen. Hopefully you never need them, but they're definitely better. You have that better safe than sorry. It's one of those controls. So that covers our secure data center. We talked about the logical, the physical, and the environmental design. Now moving on to cloud infrastructure. So any IT infrastructure, it comes with a certain level of risk. It's always important to analyze those risks and determine the best ways to treat them. Many of the risks that come with cloud infrastructure, they're the same as traditional on-prem, but some are unique to cloud environments. And as a CCSP, you have to understand how to identify those unique risks, okay? How to assess, analyze them, and what are the mitigants. So there are several categories of them, which we'll take a look at. What are we talking about? So there's organizational risk, compliance and legal risks, cloud infrastructure risks, and virtualization risks, okay? So these are the main risks. We'll cover them one by one. So what are the organizational risks? So these are the risks which potentially impact business processes, company policies, you know, anything else that a company views as important. So one of the things which we have to keep in mind is reduced visibility. And customers who host, they maintain their own infrastructure. You know, you have complete control, right? For better or for worse. But if you run your own data center, you can change what you want, when you want, and you have full visibility. Moving to the cloud means that you give up some of that control to the cloud provider. So you need to have a very mature governance model prior to migrating to the cloud, and you have to find ways to mitigate or accept any risks which are there pertaining to, you know, control, service level agreements. You need to have monitoring, but your level visibility goes down. Staffing and operational challenges. So cloud migration can introduce challenges for existing IT staff who are not properly trained on cloud computing and security. Suddenly, you're putting them into a new environment, right? This requires a lot of training for existing staff or maybe new people to be hired. The skills gap, it can create the potential for security risk, right? Misconfiguration, I talked about. So you have to proactively evaluate your current staff and find out. And vendor lock-in. So vendor lock-in we talked about earlier when we talked about platform as a risk, platform as a service, right? Vendor lock-in becomes an issue when you've like invested a lot into a service provider, a cloud provider, and you want to move that data. So it becomes a big issue sometimes if the cloud provider does not provide you enough tools to quickly migrate your workloads. It can become a big problem. Lots of changes have to happen. Lots of money is lost doing it. And lastly, financial management. So most customer organizations, they are accustomed to setting a strictly fixed IT budget every year, right? And if you exceed that budget, what happens? It gets carried forward or gets wasted. But moving to the cloud, customers are built for exactly what they use. You know, it becomes like a metered model, which we talked about earlier. And cloud utilization cost can go up and down. Instead of like a static number, it can go up and down unless you are very careful and you understand what's happening, right? So these things you have to take into account from the organizational perspective. So compliance and legal risks. So here we're talking about from the regulatory perspective. So customers in highly regulated industries, you know, such as financial services and healthcare, they need to be concerned with data security and privacy regulations like PCI DSS, HIPAA. So moving to the cloud is still the customer's responsibility to make sure that your data is secured and as per the regulations. So you have to, and as well as any contractual commitments you made to your own customers, right? So you need to make sure where the data is, who is going to be accessing it, and how the data is going to be protected. So you have to know what the cloud service provider role is. This is where the shared service model comes in, right? Some of that responsibility is transferred to the provider, some of it remains with you. But you have to make sure you know what you will be doing, what they will be doing. Sometimes cloud service providers, they give customers a document called a customer responsibility matrix, which like tells you what is the CSP responsibility, what is your responsibility within each regulation, like from PCI, from GDPR, from HIPAA. So it's definitely recommended to download that and go through it. Okay, now we moved on to cloud infrastructure risk. So cloud environments, like they talk about, they experience the same type of threats and vulnerabilities as on-prem, right? And so let's take a look at one by one. Management plane we talked about earlier. It's probably the most visible target, right, for cyber criminals, because it's a single interface. It gives you access to all the resources. If an attacker is able to compromise this, it can affect your entire cloud environment. And because they've made available to customers through public-facing APIs, they're widely exposed. The attack surface is quite large. So attackers, they look for weak APIs and they can exploit vulnerabilities to break through and get access to your data. The second one is incomplete data deletion. So like we've talked about earlier, when cloud customers delete their data, they're relying on the cloud service provider to actually remove all traces of that data, right? And you have reduced visibility into where all components of your data reside. So you have to make sure that the cloud provider is giving you that attestation that they have deleted it. And what is insecure multi-tenancy? So we've talked about it earlier, right? On a single server, on a single physical resource, you can have hundreds to thousands of customers sharing the same hardware. Now, this requires the cloud provider to use isolation, you know, logical isolation to keep them separate, right? And what happens if these controls fail or they don't exist? So without proper separation, an attacker can gain access to one tenant and compromise the other tenant also. And this will give you unauthorized access to data, denial of service. I mean, you can think about pretty much any tenant to tenant attack, right? What else is there? Resource exhaustion. So resource exhaustion happens when one company is denied resources because the resources are being completely consumed by another tenant right? They might be spinning up something like a huge, massively powerful processing is happening. It's going to use up all the resources on their hardware. And what is going to happen is other companies will not be able to use their tenants. They will not have access to the resources anymore. That's why it's so important to set up rate limiting and put in limits to stop customers from breaching up a certain point. And lastly, network OS and app vulnerabilities. This is quite simple. CSPs are responsible for scanning and patching, like their area, but you have to make sure that the perspective from your network OS, all those are patched, because unpatched vulnerabilities, they present a risk to the customers, right? And what do you call? Unlike in traditional data centers, it is divided between you and the cloud service provider. So you have to make sure you're doing your bit as per the shared responsibility model, and the cloud service provider is also doing the same thing. So we talked about virtualization earlier, right? Now we're talking about virtualization risk. This is quite an important topic. That's why the CCSP keeps mentioning it. And from the perspective of virtualization, because the virtualization is such a complex topic, you have more things to understand, and you have to think about what are the risks which are there. In 2015, the Cloud Security Alliance, they published a paper like what are the key risks. So they mentioned certain risks and they divide it into three categories, which is architecture, hypervisor, and configuration. So let's take a look at it. So from the architecture perspective, they are directly related to the abstraction between physical hardware and virtualized systems. So this abstraction, because the hypervisor is separating, it's not letting you see the hardware, it's not letting the hardware seeing the virtualized system. But because of this abstraction, there is an added layer of complexity that presents a risk to virtual machines, like running on a cloud environment, because you don't have visibility or control into the virtual networks, right? You can't monitor virtualized traffic as easily as physical traffic. Resource exhaustion, we talked about this earlier, right? And workloads of different trust levels can be on the same host. This is because of the multi-tenancy. Because what happens is you can have a very, very sensitive customer on the same hardware and another customer which is completely unsensitive and they're running all sorts of resources. So that's why some cloud providers, they give you controls like you can have a dedicated server. It costs more, but then you have that assurance that it's not being shared with any other tenant. Okay. And risk, of course, due to the cloud service provider APIs. We talked about this earlier when we talked about the management plane, right? It's the same thing. Okay, the other one we moved on to, the second one risk category was hypervisor. So hypervisor we talked about, it's pretty much the main heart of virtualization, and this is where a lot of issues can also happen. So there's the hypervisor security, right? If you don't manage it properly through the life cycle, the hypervisor might not be patched. It might have many vulnerabilities, and if it gets compromised, it'll give access to all the other VMs also. You can get unauthorized access to the hypervisor because it's like the holy grail of virtualization. If you don't have proper access controls, that can be a big risk to cloud customers. And again, you will get access to all the data, which is there, all the VMs. And lastly, account or service hijacking through the management portal. Same one we talked about earlier when we talked about the management plane, right? If the management plane is compromised, you could potentially get access to the hypervisor because you have admin access. Okay, and last, we're talking about virtualization is the configuration. Yeah, this was the last one. So like we talked about earlier, virtualization, the good thing about virtualization is it speeds up. What does it speed up? It speeds up the creation of computing environments, and without careful attention to secure configurations, you can quickly spin up a very, very large environment, right? Without proper security controls in place. And what can happen? You can have things like VM sprawl. What is VM sprawl? It's the uncontrolled growth of VMs to the point where the cloud administrator can no longer effectively manage and secure them. And you can put sensitive data with a VM. Remember, VMs are just files, right? They can be moved from place to place. And if you don't have controls like encryption and access control, somebody can easily gain access to that sensitive data. And security of offline and dormant VMs. We'll talk about this later in the virtualization sector, but these usually are centered around VMs. And you have to make sure that once a VM is turned off and it's no longer being used, nobody can access it because it can still have access to residual data, right? You have to make sure that compromise cannot happen. Okay, onwards to the next topic, which is designing and planning security controls. So this chapter, what it does, it covers the core capabilities of cloud infrastructure, and many of the risks which are associated with migrating your data to one of them. I've touched upon some of these things you can do to mitigate, but this section dives deeper into those security controls. Okay, we've talked about some of them, but let's going to do a more deep dive. So we talked about the controls which are there, right? Physical and environmental protection. You need to have these things, implement these controls over your physical hardware, and to make sure that security is there. Okay, So things like we can go on and on. You need to have like things like the server rack. Like the server rack has to be there to protect your servers. You need to have proper networking equipment. You need to have a HVAC, which is there for ventilation and air conditioning. You need to have fire suppression systems, and of course we need to have power distribution, right? This maps back to those risks we talked about. So all of these are the controls which have to be put in place to mitigate the risks we talked about earlier. Otherwise, what else do we have? Physical security controls, right? These are you need to have policies that address the purpose and scope of physical environment protection. Procedures are the same thing. You need to have mechanism to restrict access to data centers, servers room, other sensitive locations, right? Background screening. You need to make sure that the people who have access to critical systems, they have been vetted. You need to have physical control like fences, walls, trees, badge readers, and fire suppression, right? Water damage protection, humidity control we talked about, and of course backup power. And the backup power and redundant telecom capabilities have to be there. And then moving on to the system level. So when you talk about system and communication, so remember that at the end of the day, cloud infrastructure is still a collection of physical systems that are communicating with each other, like this, like traditional servers, right? And you need to have things put in place. What is this? You make sure that the data which is at rest, that is being encrypted, right? And the primary control there is protection, encryption. So you can, and for integrity and availability, you can put things like hashing and redundant storage. The other one is data in transit. For data in transit, there's encryption again, right? SSL, HTTPS, that is there to make sure that when the data is traveling, nobody can look at it. And data in use. So data in use is again, you can put in controls like encryption, digital signatures, access control over your APIs. And system and communication controls, the other controls also are there, some additional things apart from those. Policy and procedures, again we talked about this already. For everything you need to have proper policies and procedures. Isolation, so you need to make sure that your sensitive functions are what you call isolated from your non-security functions. And of course logging and monitoring when traffic is being passed from your systems, from your network. You need to have a firm understanding of where the cloud service provider is monitoring and where you're monitoring. So make sure that you understand this shared responsibility model, and you know that what your security responsibilities are. Okay, so virtualization system protection. We talked about virtualization, right? Now what we're going to talk about. So virtualization system protection, you need to make sure that vulnerability and config management is there, right? You need to make sure that we talked about the hypervisor security, right? Because if one hypervisor is broken, it can gain access to all of the other VMs. You can gain access to data of all of the VMs. So you need to make sure that hypervisors are hardened, and you have it's hardened as per the best practices. They are being scanned, they are being pen tested, proper access control is there, right? Access privilege, you need to make sure that the least access privilege is there, RBAC is there. And as a CCSP, you need to make sure that who is the admin access, like who can modify change settings, who can download, like downgrade settings, all those things have to be there. And you have to make sure that the logging is there from the networking perspective, right? You need to make sure that all the traffic which is being passed, that is being logged, all the actions which are happening are being logged. So all of these things come together to make sure that your security is being implemented properly. So when we talk about virtualization, in the traditional data center, network perimeters are pretty easily defined, right? You draw an imaginary line around your internal stuff, and that's where your internal stuff is there. Then you have something like a DMZ, then you have an untrusted zone. But the same thing, you need to think about it in virtualized environment. The risk is slightly different because the system is being shared, right? And you need to think about it in a different way. That is why zero trust is so important. And it's definitely very, very important from the perspective of virtualization. So you need to define something called a trust zone and make sure that that is properly implemented. So what is a trust zone? Trust zone is a network segment that includes systems and assets that share the same level of trust. So the DMZ internal network, like when we talked about, right, they are example of trust zones, right? So network traffic within a trust zone that can move freely with few limitations. However, traffic into and out of a trust zone is more closely monitored and restricted, right? So there are many strategies for developing trust zones. It's up to each cloud service provider to identify the strategy, which works for them, right? So this diagram, you can see that this is an example of like a trust zone. So what do you call? This is how it looks like, right? So you can see you have the management zone, which is the hypervisor management plane. You have a DMZ. Yeah, you've created these separate trust zones, and it's a great way. So if you're connecting to the management zone from another zone, you have to go through the zero trust model, right? You have to make sure that everything is being authenticated before you can access another trust zone. So in this way, even if somebody is accessing and compromises one zone, that does not mean he's able to access the other zones also, because of the whole zero trust controls which we put in. So I hope you understood what the benefit you're getting and the benefits which zero trust is bringing to the virtualization security. Okay, what else is there? Again, apart from that, we have identification, authentication, and authorization. This is pretty simple stuff. Not going to take too much on this. I mean, identification, is basically you uniquely identify every person in the cloud, right? Through a unique identifier, user ID, a machine ID, something is there. Authentication is basically proving who you are, and authorization is what you can do. Okay, and this is pretty basic stuff. But we have, as a CCSP, you have to understand a few things, which is these standards like SAML and OpenID and OAuth. Okay, because a lot of cloud providers, they use open standards like OpenID and OAuth. They have become, so you should be familiar with this and for the exam and understand what they're being used at a high level. Okay, the nitty-gritty details you don't need to know, but you need to understand. Simply put, SAML is like an open standard for single sign-on, right? For federating access. We'll talk about this. OpenID is used for authentication and OAuth is used for authorization. So OpenID was created for federated authentication, meaning it lets a third party, like a third party, authenticate users for using accounts you already have. For example, if you already have accounts in Active Directory, you can use OpenID or SAML to authenticate to that, and you don't need to create new IDs in the cloud, right? You can use that. And OAuth was used for most for authorization. Okay, so if this is how it looks like, right, from federation. When I talk about federation, it's the process of linking your identity across multiple applications like on-prem and cloud. So if you are a user, you can just authenticate to the identity provider. In this case, it might be Active Directory, and then you can log into multiple applications on-prem, your on-prem applications. It might be the cloud, Azure, AWS. If you've ever used Okta or Azure AD or those other things, this is pretty much how it is. These are the things. This table is very nice. It tells you the different, like what are the different things. This is just for revising. So you have SAML, you have OAuth and OpenID. Remember, SAML is used for both authorization, authentication. It uses XML, right? And you use more of a single sign-on. OAuth is like open standard for authorization. It's used JSON. OpenID is authentication. So just use this. It'll help you to keep in mind, and this way you won't forget. And okay, what else is there? Log collection and packet capture. So auditing, it plays a major part in ensuring that systems, comply with legal, regulatory, security, and other requirements. In a cloud environment where you have so many customers, sharing single infrastructure, there's no way for an individual customer to do their own audits, right? But you have to understand this, but you have two specific mechanisms, which is log collection and packet capture. So while cloud environments make it very easy for customers to locate and aggregate their data with a management plane, but you have to understand that you will get more and less logs depending on what model you are taking because of virtualization, right? And you have to think about this. So like if you're using an IaaS, infrastructure as a service, you will have more logs. But as you go up to platform and software as a service, more and more responsibility is taken by the cloud provider and you don't have to worry about it. The second one is packet capture. Packet capture is pretty much the same thing. So, and it's again dependent on the cloud service category. If you're using infrastructure as a service, you can probably do packet capture activity on your VMs. But your platform as a service and software as a service, you are limited to what the cloud service provider is willing to share. So yeah, as a CCSP, you have to ensure that your organization understands what data is available and you can make an informed decision based on your company's risk tolerance and business needs. Okay, moving on to the last topic, guys, which is BCP and DR. So this is quite important. I mean, as a cloud service provider, I mean, the cloud lends itself very well to business continuity and disaster recovery, right? Because they're spread across geographically at such a large location, to the level of availability, it simply cannot be matched by on-prem. But as great as these features are, you have to take into account certain risks and other factors which we plan for. So when we talked about the BCP and DR, like I mentioned, traditional BCP and DR risks, they do get mitigated a large degree to the cloud due to its vast nature, like things like natural disasters, DDoS, ransomware, fire, explosion, equipment failures, power outages. All of these things, what is happening is because of the cloud provider, they are handling the data center, right? And they have massive budgets. They've spread across their data centers. They've already architected it to make sure like they are not subject to these risks in any one point. And all of these data centers are connected through like high bandwidth, low latency links. So they have controls in place, so you don't have to worry about it that much. That risk will always be there a little bit, but it's mitigated to a large degree. And of course, from the BCP DR strategy, this is pretty much the standard. I won't spend too much time on this, guys, because this is pretty basic stuff. I mean, these are the stages from the BCP DR. You have to scope, and like when you're thinking about your BCP DR strategy, you have to make sure, like, assess which are the critical things you have to be protecting, make the scope, create and design your BCP DR, architect it, think about what regions you can copy to other regions, other data centers, implementing the DCP, and then doing your testing and reporting, doing your tabletop exercises and other testing. Like I said, this is not just specific to cloud. This can be anything. So I won't spend too much time on this. And that brings us to the end of domain 3. Thankfully, it's not as big as domain 2, which is a relief. But again, like I said, it does account for a large part, and it does build upon the other things which are there. So I hope you understood this, guys. If you have any issues, let me know in the comment section. Thank you very much. Do like and subscribe to this channel, and I'll see you.